Here, my glasses.
Hi everybody, I'm Philipp Stiefel and I know nothing. And if we got a couple of minutes at the end, I'll explain why I say that. But this is not about me, it's about the Windows 64-bit API in VBA. So we'll dive right in. What is the use case for 64-bit? I guess you know it, every one of you knows it. We've got a bigger address space. That is common knowledge nowadays. But the magnitude of it, that is something I need to remind myself of because I forget it. With a 32-bit operating system, we had 4 gigabytes of addressable space, and it's actually less than that, but let's not go into that detail. And with 64-bit operating system, we have up to 1024 gigabytes of physical memory that can be addressed, and up to 16 terabytes of virtual memory. These are the numbers for Windows Server, but that is showing what's technically possible. The desktop, the professional desktop edition of Windows has much lower numbers, but they are artificially reduced to provide an incentive to buy the server edition if you really need that. That is something we should keep in mind. So, luckily, Access supports 64-bit, and for quite a while now, since Access 2010. And with Access 2010 came the VBA 7 extensions for 64-bit. And these are quite useful because otherwise we couldn't do anything with 64-bit. Sometimes people are unsure which version of Access they are running. Luckily, Luke has explained that earlier on. You go to your account in Access and open the About Access dialog, and at the end of the long version number there is the 64-bit designated if you are running 64-bit. So, what benefits does 64-bit Access actually have? Not much. There's one issue I can absolutely reproduce. If you got multiple forms that you're displaying at the same time, and each of it has multiple subforms, then you might actually run into an out-of-memory error. And I don't know the exact error message right now, but it's literally saying we are out of memory, and then the best you can do is close Access and start again because it's becoming a bit dodgy then. And that is something that I can easily reproduce on a 32-bit system, but I wasn't able to reproduce that yet on a 64-bit system in a real-world scenario. So that is definitely an error that is fixed. And another error, I have not really verified that myself, but someone else told me about it. If you've got a report with lots and lots of images in it, and you open that report multiple times, after 2 or 3 times, the report will still open, but all the image areas stay blank. The images are not displayed anymore. And the person who reported that says that this has become much, much better with Access 64. So it seems to be a memory issue as well.
So you can use my glass, so you don't have to reopen the report.
Well, it doesn't help if the pictures do not show. I can reopen it as many times as I want. That does not help at all. Does anyone of you know any other real-world benefit of using Access 64-bit?
Not for my customer, but for me.
Huh? Speed? No, I have not noticed any difference yet.
So,
Yeah, Jack?
I'm not sure 100%, but I think sometimes in running very complicated queries that may take a long time to run, the system memory that Access can use to process those queries, I think can be a little bit more with 64-bit than 32. So you wouldn't usually notice it if you have a really nasty report with a lot of
Okay, thank you. I'll take a note of that. Kevin?
So we actually didn't do any work specific to 64-bit other than 64-bit. It seems like Excel and Project actually made performance improvements in 64-bit.
Yeah.
The Access was just along for the ride. It was a mandate after the 64-bit version.
Maybe we should say that Kevin was in the Access
Oh yeah, I was from 2010. Yeah. We blame me for the web editing. Actually, I was fighting hard to. Yeah. So there was no physical work. So it should work just the same. There's no speed performance inherent, but with memory issues, maybe you'll get some performance, but there's nothing. We didn't code anything faster. So it might have just come
Okay.
up for the ride. But didn't do anything specific.
Yeah, great. Thanks a lot for that input. So actually, can we ignore Access 64-bit altogether? No, we can't. These two are the drivers of 64-bit adoption, and you cannot get around it in the long term. On the right or left from your hand, it's business people, business decision. Someone pretty high up in the hierarchy of your client or in your own company says, we are using 64-bit Office from now on, deal with it. No discussion, just get on with it. That happens quite a lot nowadays when businesses upgrade to the next Office version. They decide, yeah, we go for 64-bit, and that's the way it is. And as Luke earlier explained, you cannot install Access 32-bit next to a 64-bit Office. So then you have to deal with Access 64-bit. And the other driver, Kevin mentioned it, is Excel. Excel actually benefits from 64-bit. If you got a client in the financial industry, I've got a couple of them, and they run huge financial risk models in Excel, they actually benefit from using the 64-bit edition. So that might drive their decision to use 64-bit. Yeah, bitte?
There is one more project.
Project, okay.
We are heavily using 64.
Okay, that might actually be true. I haven't heard about it, but there are external causes. Yeah?
Often it's not Excel itself, but Power BI and Power Pivot and so on. The add-ins that Excel uses for the BI things.
Might be true, yeah, but it's somewhere centered around Excel. So, well then, there is a 64-bit edition, and we just used that and are done with it, aren't we? No, unfortunately we're not. Luke told us quite a bit about the problem with ActiveX controls or COM libraries. Some of them are, or quite a lot of them, are actually not available for 64-bit. Especially if they come from that dodgy company from Redmond, they are not particularly keen to update their stuff to 64-bit if they developed that some time ago.
Well,
But yeah, but Luke also mentioned that the common controls are available for 64-bit. I haven't tried them either. I will do whenever I find the time, but I haven't yet. So there's not much to say about that. Another problem might be, that is much less common, that you connect to some external system, some legacy database application, that you need a driver or a kind of a provider to connect to that external interface. And that is not available on 64-bit. Might happen. It's quite rare. If the system you're using as the other party you connect to, and it's well maintained and updated, you should get a 64-bit connector to it. But it's not guaranteed. You should definitely check before you decide to move to 64-bit if you have a say in that decision. So the first two, we cannot do much about them. It's third-party problems. Either they supply a 64-bit solution or they don't, but we can't do much about it. The third point is that what I'm going to focus on today, because that is something we as Access developers can actually influence and make work. The migration of API declarations. So, the Windows API and 64-bit VBA. Just a very quick recap, what is an API? Nowadays, we think of REST APIs on the web. That is an API too, because an API is just a defined interface to some external functionality that I can program against and use to use external functionality. That's not, well, it's included what I'm talking about, but I'm not talking about REST or something. Let's narrow that down a little bit. I'm talking about libraries, mostly DLL libraries that have entry points, that are not COM libraries like our Office object libraries, but DLL libraries from the operating system that were mostly written in C or C++. And I narrow it down a little bit more. I'm talking about the Windows API. DLLs that provide Windows functionality for us as developers. So, question for you. Who has never used the Windows API in any one of your projects? No one. That's what I expected. Great. So, before we focus on the VBA part, just a little bit on the requirements of such an external DLL. Because we can use lots of DLLs, but we cannot use all of them. There are limitations. If you want to call an external function in a DLL, that function needs to use the standard calling convention. And that implies something about its internal workings, how the stack is laid out. It needs to be right to left stack layout, how the arguments are passed into the function. On 32-bit, the register EAX will get the return value. It's a little bit different on 64-bit, but that does not matter much. And the callee, the function that is called, is responsible for cleaning up the stack. That are the requirements internally to that library. So if you get a third-party library from basically anywhere, and it says, yes, it has an API, it's a C library, we can call that from external components, unless they specifically say you can call it from VBA, you should check which calling convention does this library use. If it uses standard call, you're fine, you can use it. If it uses anything else, there are problems, really, really huge problems, and unless you want to fiddle with it for quite some time and do some really serious API memory hacks, you cannot use it. So standard call it has to be, and sometimes you'll see the calling convention bin API. That is an alias for standard call. That is what Microsoft used to use as name for their calling convention, but they kind of abandoned that name. They are using standard call at the moment to describe that, and it's exactly the same. So, this is the most simple API sample I could think of. It's just the sleep function. I'm not going into much detail here, but I'm explaining a little bit about what these components actually mean. Declare indicates this is an external function. It's not a function we've written ourselves, it's an external library function. The name is the local name of our function that we want to use in our code to call it. The lib is the name of the library. That is actually quite important. That is the DLL name, and you can either use the name on its own or the full path to the library. If you just use the name on its own, then the dynamic link library resolution, library search order, will try to find that library. It looks in a number of places like the application directory, the system directory, and the Windows directory, and a couple of others that depend on how your computer is configured. And that is quite convenient if we are actually using Windows DLLs. because they will most likely be either in the Windows or in the System32 folder. So they are automatically found even if we just use the name for them and not the full path. And quite important to note, the lib part is a constant. We cannot supply a dynamic value for that. I'll talk about that in a second. Now the alias is the real name of the entry point into that library, the real function name. And that usually is a name very similar to the name we actually use. It sometimes has an A or a W attached to it to indicate it's an ANSI or Unicode function. But with some libraries, you don't have a decorated name. You just have some @7305 or something if the developer of that library did not bother to export a name for that function. Then you would use that cryptic entry point identifier as a name. And this name is optional if we use the same name internally, but I wouldn't recommend to do that because it's case sensitive. So it's rather recommended to use a dedicated string to name that external entry point to the library. Well, the parameters are an essential part of as well, of course. We'll talk about them later. Has any one of you used the MSDN specification of a Windows function to write an API declaration by scratch? 4, 5,
Maybe.
5.5. Yeah, not many. Just curious, because then you probably know quite a bit more about the internal workings and what I'm going to talk very soon. But the majority did not. So we continue here, and I will do some things a little bit more extensively later. I come back to the lib, because that is nothing to do with 64-bit, but it's a so common problem that I think I'll digress for a second to that. You sometimes have got a third-party library DLL that you need to call from your code, and you cannot know where exactly that is installed on your computer. You can find out by searching for the file programmatically, but you cannot hard code the path inside your API declaration. So as the library name is a constant, you've got a bit of a problem here. But there's a simple solution. You can use the load library API function to dynamically load a library into your application's memory. Then you kind of build the path as a dynamic string from the information you have, load that library into string, and in your API declaration, you omit the path completely, because if that memory, if the DLL has been already loaded into memory, then the DLL of that name will be found and used regardless if the path matches, if it's the same that you intended to use. That does not matter. If the name matches and you got such a DLL loaded into your application's process memory, that one will be used, and that is a good option to use a dynamic path to load an external library that is not part of the operating system. Yes?
So the load library function searches for the DLL?
No, you need to provide the path yourself, but you can build the string, like you write a routine to search for the file, or you let the user select the file or something, and you have a string variable that can be dynamic.
Because I wonder, how does it work that sometimes you just put it into the application directory, for example?
Yeah. The application directory is one of the locations that is searched.
Automatically?
I think automatically, yes.
I ask.
It depends a little bit on the configuration, but usually it is among the first or the very first locations.
Because that's not my question, but for the tool that I present later, he has this question. Because he wants to be flexible and can place it everywhere, this DLL, and he doesn't know how it works.
And what's this ambiguity?
Yeah, we can speak later.
Yeah, that is a problem. Sometimes you cannot put the library into the application directory because it has to be installed by an administrator, and he installs that today in this directory and then tomorrow in that, and maybe it was previously installed and whatever. So that is an option to deal with that kind of situation, that you do not know while writing your application where that library will be located. Okay, now let's focus on the migration to 64-bit. The first thing I would like to stress is there is no change to the built-in data types when you use 64-bit VBA. An integer is still 2 bytes wide, a long is still 4 bytes wide, and even the external types, the D word that maps to a long, is still 4 byte wide. If you're programming in C, your int data types retain their size, their long data types. There is no change to the existing data types whatsoever. They all stay the same. That is quite important to keep in mind sometimes. So, earlier on I said we've got the VBA 7 extensions to VBA for 64-bit that kind of give us the ability to support 64-bit. And earlier someone said to me, yeah, I throw a couple of pointer saves in the functions and then everything's good. Well, maybe not. The pointer save keyword is required to run API containing code on 64-bit. You probably know the error message that specifically says you need to use the pointer save attribute if you run old code on 64-bit, or if you try and it does not work. But it's quite important to note, pointer save itself has absolutely no functional effect whatsoever. None, a zero. What it does is that you tell the compiler, I, the developer, I checked this code. I made sure it is pointer safe, and I confirm that by inserting the pointer safe attribute. That is everything it does. It has no effect on the code itself. None. Now, the next extension is a new data type, the long. And that is actually only available if you're really on 64-bit VBA, not in the 32-bit edition. And that is a true 64-bit integer for VBA. You probably are not going to need it if you're in the process of migrating, because you haven't had it before and you're not going to need it afterwards unless you have some very specific functions that actually need it. It might happen, but it's not likely in the migration process. Much more interesting, and that is a key data type that is new as well, the long pointer. And that is a hybrid data type. That is a data type that is actually changing depending on the environment you're in, because it is a normal long internally, a 4-byte long on 32-bit, but it becomes a 8-byte long, kind of a long internally on 64-bit systems. But we can use the long pointer data type on both platforms, and it will behave according to the platform it is on. And finally, there are two compiler constants that are new with VBA 7. The first one's pretty obvious. VBA 7 just tells you, yes, we are on VBA 7, not on an older version. That is really important, and I'm telling you why. And the Win64 compiler constant. And everybody thinks, yeah, Win64, that's what we're going to need, and that is really important. No, it's not. In almost all cases, it is not. Because unless you support very old Access versions, before Access 2010, that do not use VBA 7, you do not need to care about that quite a lot. Because your code, you can easily write code that runs on 32-bit and on 64-bit. That is pretty easy. You need to recompile. That is something you need to keep in mind, but you do not need to change the code. These compiler constants, they become relevant if you need to support older Access versions, Access 2007 and older. Then you will actually use the VBA 7 constant to conditionally compile the new code, including the VBA extensions for 64-bit and the old code. But otherwise, you don't need it. And the 64-bit constant, you actually only very, very, very rarely need to use that at all. Because it will tell you if you're on 64-bit. But most of the time you don't care, because your code runs with 32-bit and 64-bit. You just don't need to know. Only if you have some very specific code that is different on 64-bit. And that is rather unlikely, I would say, with Access. So care about VBA 7 if you have to support older systems, not so much about Win64.
So the Win64-bit is just for cases where they changed actually the API function, for example?
Yes, and I'm not aware of any case where that is true. There are a couple of API functions that are new on 64-bit, that have been added to the API and that are only available on 64-bit. But I do not know of any API call that has been changed from 32-bit to 64-bit. Well, there are some internally, but you usually do not need to know about that. Yes, Jack?
We actually did run into one of them. We do a lot of API work, we're used to, but there was one function, I think it's set window long, where if you're using the 64-bit, you actually need to call a different function for it. There's a different function name for the 64-bit.
Yeah, it's set window long pointer. Yeah, and you can safely kind of ignore that, because the other function you're supposed to call set window long pointer, that is internally a kind of wrapper that either wraps the 64-bit or the 32-bit version of that function, depending on what platform you are on. Yeah, you usually do not need to care about that. But that would be actually an example for that if you would deliberately use the other function, the 64-bit function. But that is really an example, an exception to the rule. But one thing you shouldn't ignore is the calling code. I quite frequently see, people just migrating their API functions and leave the calling code as it is. And yeah, well, I talk about the common data types, and then I show an example that clarifies what I mean. So if you migrate your API functions, you can leave all the integer data types as they are. If they are integer and long, you can, and they just mean normal integer and long numbers. That is the important point here. Then you can leave them as they are. But if you've got long values that represent handles and pointers, then you should change them from long to long pointer, because then their size on the platform will actually increase from 4-byte to 8-byte on 64-bit. So that is something you should address and should regarding all those handles, and you absolutely have to for pointers to memory. And I'll go into a bit more detail later on. Strings do change as well, but we can ignore that because that is all handled internally by the runtime. And if you use arrays and have declared them as that mysterious data type that is not really defined, there are no changes as well. So let's look at a small example. So Is that big enough to read from the back rows? Okay. So what I did here is I actually used the VBA 7 constant here, here it is, to conditionally compile different variants of my code, one for VBA 7 and one for the older version. And you see down here, that is marked red because it does not comply to the pointer safe requirement, but we can safely ignore it because this code is conditionally compiled and it is not compiled in this version. I can go to debug and compile this database, and it is compiled. The code is marked red because it has the potential problem of the missing pointer safeness, but as it is only conditionally compiled and the condition does not apply right now, it does not cause any problems. And quite important to note, if you create an AccessDE file, that code that is marked by conditional compilation not to be compiled in this environment, it will not end up in your compiled AccessDE. So if you support old versions of Access and new versions of Access, you need to compile two different versions, and the third one for 64-bit, as Luke earlier told. So it is a bit of a maintenance nightmare coming there, but at least you can use one code base. You do not need to change the code and have different code bases for each platform, but you need to compile it 3 times if you want to support 3 different environments. So now let's look at an actual function call here, and that is what I mean by you need to adapt the calling code. What happens here is I use the find use the find window API function. Yeah, I cannot draw with the touchpad, it looks horrible, but anyway, I use that function that will return a long pointer value. So I need to have my local HWND variable needs to be a long pointer, because otherwise it would not be big enough to store the value, because I then use that to pass it on to the show window function here later. So the calling code needs to be adjusted as well. So that was the demo. User-defined types. And now it's getting really, really serious. Of course, well, is everybody where I talk about public type, blah, 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 and then a list of members and end type. That's what I'm talking about. We can skip ahead. That is what I'm talking about, a public type. User-defined types. Of course, you need to change its members according to the rules. If you got window handles, if you got pointers and stuff like that, you need to switch from long to long pointer. That is obvious. Now, user-defined types have its members lay out in memory sequentially. So one by the other, by the other, by the other. And quite a lot of those types want to know their own size in memory. So on 32-bit, that is pretty easy. All the members will be arranged in 4-byte chunks, and then sequentially one after the other. That's the way it looks. There goes the long, that is the long pointer. That is 4 bytes here as well, so it nicely fits in. Another long, and yet another long. So that is the memory filled for that type. And quite frequently, people get the size of that type by using the len function. And the len function will add up the sum of the length of all those data types and will end up with 16 bytes. That is quite frequently done. And in this case, you can easily count it's correct. By chance, only by chance. You should rather use the len binary function. That will actually return the size of the type in memory. It is 16 bytes as well in this case, so obviously this is correct. And that is what you should use. Because, now let's look at this at 64-bit. Now our memory chunks where the type will be put in are 8 bytes in size. So for the first long, it's pretty easy, fits in. Now comes the long pointer. Oh, that's a bit big. It doesn't even fit on the slide. So it cannot be there. And it will not be broken up in 2 different chunks of memory. So it is moved to the next chunk. And then the 2 longs pretty easily fit together in 1 chunk of memory. So our memory for that sample type is laid out in that way. And now, if you once again use the len function, it will give you the sum of data length of all those types, and there are 20 bytes. And that is wrong, because we do not want to know the sum of the parts. We want to know the total memory occupied by that type. And we need to consider those 4 empty bytes in the first chunk. And the len_b function will actually return the correct value of 24 bytes here. So, just quite a quick demo. So, this is what I've shown. Oh, sorry. There is something going wrong here. Okay, sure what happened there, but it's gone. So this is the sample type I showed you, and this is a tiny function that just returns the len and len binary values of that. Let's start with that. So here we are. You see the difference as I've shown on the slides. Len returns 20 bytes and len_b 24 bytes. That is kind of an example to show the mechanics behind it. Now I've got a real-world example that is actually copied from Access, an excellent forum on the web I use occasionally. And someone was asking, he has this code in here and it's not working. Why is it not working? He did it actually quite good and right. He converted the long values to long pointers if they were handles, and didn't convert all the other longs that are not handles or pointers. So he made it almost right, but then he had this function that uses the struct declared a minute ago, and now I actually ran that function. I've added a little bit debug information, so you can probably guess what the problem is, but nothing happened. And that function was supposed to open a file dialog. Yes, Jack?
That was me, actually, so thank you.
Really?
Came a long way to get that question.
No, I screwed up the original code there, and because when I first started doing it, I did not know about the len_b being a crucial part of migrating to 64-bit there. So yeah, the person that screwed up the code originally, that was me.
Okay. Yeah. And that is exactly the problem. These two values differ by 10 bytes in total. So if I now use the lenB function here to retrieve the size of that struct and then run it again, you see it works. Now it displays the file dialog. And that are nasty problems that you'll have to battle with the user-defined types. So, got to restart PowerPoint here. Find the slide. So, size matters, at least with user-defined types. And that process of moving data that is too big for the current chunk in memory in the layout of such a type is called padding, just if you're curious. And so you always have to use the len binary function if the type you are using in your API declaration is requires the size of the type. And it should have become quite obvious why we need to take care about correctly converting the simple data types, that we cannot simply say, okay, we've got a long, we for good measure, we convert it to long pointer and will work. It does work with function calls, actually. With a pure function declaration, you could do that. I wouldn't recommend it, but you could do it. But you cannot do it with user-defined types, because then the size of the type would not be correct, and many API functions either do not work at all if the size of the type is not correct, or they do not work as expected. They might do something, but a little bit differently than you intended it. Maybe they crashed your computer or something like that.
Okay, so there is no error message for when you use.
It should be. Let's look. We are not. Karl, how many minutes have I got left? 10?
10 to 15.
Okay, then we can look at that. That is something I had in mind and I totally forgot. So maybe we can have a look at that. This is the return value of that getSaveFileName function. Oh, yeah, now it works. Now we are not very interested in that. We want it to not work. So I change this back to the len function here. And I call it again. Now let's see. The return value is 0. That indicates an error, but without further information. Maybe, yeah, maybe we get here something out of that. Yeah, there actually is one. I'm not sure if I can use the error function to retrieve any valid value. Probably not. Now it's just application defined or object defined. You could declare the get. Pardon?
Access error.
Access error?
Yeah. Just right over there.
That way?
Yeah.
Oh.
Doesn't make any difference. No, I think it would work if I would declare the get format error message function from a DLL and would format that error. Or you could look that up in MSDN. That would probably work. And the error message that is, the message for that error number is probably the type does not have the expected size. So you get an error message that indicates very clearly the problem, but it is a bit of work to go to the bottom of that. So, told you quite a lot about the importance of using the correct data type. And now I mess it all up by showing you something. You know the Access application object, it has an HWND, where it is it? Access app. So, that is supposed to be a handle to a window of the Access application. And we are on 64-bit Access here. And it's still along. So, let's take a quick look at the forms. They have a HWND parameter as well. Here's a form. And where is it? Here it is, HWND. And that is still along as well. So what? How can this work? And I was baffled for some time about that. But I know it. Right now, I found the solution. The explanation, rather. If you dig deep into the Visual Studio documentation where such things lurk, you find this information. 64-bit Windows uses 32-bit handles for interoperability. Only lowest 32 bits are significant. So, you still can get away for a handle to use a plain long. And Microsoft actually did that. And at first I thought, why? But it's quite clear in that sentence, for interoperability, because the type library for Access does not need to change. It still can use the long values for its HWND values of the forms and the Access application. Otherwise, the data type would change and the libraries would not be compatible anymore. And that would create a hell of a lot incompatibility issues between different versions of Access. And so they are actually quite clever of only using the first 32 bits and just leaving the value as a long. But it is confusing, very confusing, because you might get the idea you get away with that all the time. And you don't, because in the types, as I explained, the size matters. And if you got real pointers to memory, that is something different than a handle. Then you will very, very likely experience situations where you got a full 64-bit long value as pointer, and where not only the first 32 bits matter, but all of them. So, while it is safe in some situations to ignore the problem, you still need to be aware of that to probably deal with it and probably assess any situation and decide how you go about it, and if it's safe to cut corners and use the old long value, or if you need to be very precise and use all the details that should be there. So, we are almost at the end. A couple of links to resources. There is, you get the slide, so these links are clickable then. So the first one is the MSDN Windows API Index. That is the reference for Windows API work. And there are lots of useful informations to the API function. If you not just copy and paste them in and hope they run, but if you want to achieve something special where you need to think about and know about the inner workings of the API functions, go to the Windows API Index and read the documentation of the function, especially the remarks. That is usually where the juicy bits are. Well, the next link is to the text file for the API text viewer. I'm not sure if there's a new version of the API text viewer that works on 64-bit, but Microsoft provided a new version of that text file that contains quite a lot of API declarations for Visual Basic, and you can just download the text file. Even if you haven't got the API viewer, you can just use any text editor and search inside that file for the declaration, and then you find it in a file and just can copy and paste it into your project. And that has the convenience that the complicated types are declared correctly, and you do not need to bother to find out what type exactly which member should be. Just copy and paste it in there, and then you're usually good. Spy++ is a really, really important tool if you work with Windows. It is from the Visual Studio toolset, and I'm afraid you cannot download it on its own, but if you got a community edition of Visual Studio, you should have it. And it displays all the windows on your computer screen. And I'm going to show Spy++ in a minute. Just a word on the last text. That is something I wrote about the whole topic of API in 64-bit for VBA. And Karl liked that text so much that he said, yeah, I should come here and do a presentation about it. And that was actually the first version of that text. And after that, people emailed me questions, or discussions in news groups or forums started, and people asked me questions. Why is this and that, and why and how? And I always said, oh my God, I have no idea. I know nothing. I wrote the text that Karl thinks is the best on the topic, and I know nothing. Then I added quite a lot of information, all that stuff about the user-defined types, and thought, okay, now it's covered. And then somebody asked about that, why is the window handle in x64 still alone? And I had no idea. I knew nothing. And finally, well, no, it goes on and on. There are bits and pieces where you can drill down deeper and deeper and deeper, and you still know nothing. At least I feel that way. So that is why I said that at the beginning. Do you know the Spy++ window viewer?
No.
Almost none, I'd say. So I'll at least show it to you. I hope I've got the link here. Oh, maybe on the main machine. It does not differ. It looks the same on 32 and 64-bit, and it basically works the same. This is the Visual Studio Tools folder, and there is a Spy XX. It's meant to be Spy++, but I think they did not want to have a file name with ++. It requires administrative permission, and if I confirm, you will see why. This is a list of all the windows on my machine here, and I run a quick access window, just a minute. Does not really matter. Now I refresh that stuff. That is not the most modern of tools. It is quite annoying because all the tree is reset once you refresh the stuff. But here we are. This is our access. I'm going to zoom in a second. I just will expand this because I can't do that when in Zoom. So not doing too much here. So this is where we are. So So you see, this is Microsoft Access. That is my sample database used for that project. And the SPY++ viewer, it shows you all the windows that are in that project. And it would show your forms windows in there as well if I would have had open many forms. And if you want to do some API work with forms, like modifying them, moving them around, hiding them, displaying them, and do stuff like that via the Windows API, you need to have the Windows form handle, and you benefit if you got this view to see the structure. Okay, that's it for today. Thank you very much. Thank you, Karl, for inviting me. Danke. Very technical Europeans.
So what?